Welcome to this explainer on how to build AI agents that actually remember. We're going to completely break down the 3 layers of agent memory today, fixing that goldfish-like amnesia that really holds back modern systems.
So let's dive right in by asking what is probably the most frustrating question in AI development right now. What good is an AI agent if it forgets you every single time you say hello? I mean, this immediately sets the stakes, right? It shows exactly why memory architecture is absolutely critical. We can build these systems that reason beautifully, but without memory, they are permanently stuck on day one. They literally cannot build any meaningful context over time. Here is our roadmap for today. 1. The AI amnesia problem. 2. Layer 1, short-term memory. 3. Layer 2, persistent memory. 4. Layer 3, long-term memory. And 5. The fully contextual agent. Okay, starting with part 1, the AI amnesia problem. A travel planner scenario is actually the perfect way to see this in action. Say you ask a standard agent to plan a 2-day trip to Lisbon. It handles day 1 flawlessly. Awesome. But then you start a brand new session and simply ask it to plan day 2. Well, it completely forgets your destination. It forgets your interests, it forgets the city, it forgets the itinerary it literally just made, forcing you to start completely over from scratch. The agent basically treats you like a total stranger. This is context degradation in its absolute most basic form. So how do we fix it? That brings us to part 2. Layer 1, short-term memory. The absolute most fundamental fix is managing what we call the session. A session is just one continuous conversation thread. It acts exactly like a full transcript of every single user message and agent reply. By keeping that same session going across multiple turns in an active chat, your agent adds context. It can read its own earlier messages in that exact same thread. So you ask for day 2, and the agent seamlessly adapts the plan because, well, the Lisbon context is sitting right there in the transcript. And that brilliantly brings us to our next concept, which is state. While the session is the entire conversational transcript, state acts more like a structured scratch pad. Think of it like a sticky note for the AI. You really don't want your underlying AI model wasting expensive compute power rereading 15 previous messages just to dig up one tiny value, right? State allows the agent to just grab quick facts, a restaurant name, a destination, a flight confirmation number, instantly and efficiently. Now, if you are a developer, here is a massive golden rule for you. Never modify the session object directly in your tool code. Just don't do it. If you try to hack the session object directly, the framework you're using won't record that change in its event log. And if that happens, your persistent services won't save it properly for later. Always write state through the context provided by the framework. But, what happens when the application crashes or you just close your laptop for the night? That short-term RAM is completely temporary. So let's look at part 3, layer 2, persistent memory. Think about how an in-memory session just evaporates completely on a restart. Poof, gone. Contrast that with a database session. By swapping out your storage engine for an actual database, like writing to a disk or using something like Postgres, you make that memory durable. Every message, every reply, every single state change gets saved. So if the op restarts, the conversation survives. The agent just loads up the full history and picks the interrupted chat right back up where you left off. But true persistence is also about remembering things across entirely different chats on entirely different days. To do this, the agent maintains personal facts using a small user profile store. When you start a brand new chat, the agent uses a tool to recall this profile. For example, it remembers you mentioned you were a vegetarian in a chat last week. It uses that exact data to personalize your current plan instantly. And then, before it finishes, it uses a save tool to safely record any new facts it might have learned about you today. Okay, let's move to the ultimate goal here. Part 4, layer 3, long-term memory. What's really fascinating about this layer is the sheer variety of unstructured inputs that a cloud service, like Vertex AI Memory Bank, for example, can actually ingest. We are not just talking about structured database tables anymore. This layer allows your agent to archive entire conversations, right alongside text, images, audio notes, and even video files. It builds this massive, multimodal, long-term knowledge base. And here is the autonomous workflow that makes that multimodal memory actually function. First, at the end of a chat, the system just archives the full session. Second, a background agent engine steps in, extracts key facts from all that media, and generates embeddings. Finally, and this is kind of the magic part, a preload memory tool automatically uses semantic search to inject those relevant facts into the prompt before the agent even responds to your new chat.
The real secret sauce to this layer is that semantic search. The agent isn't just matching raw text. It's understanding the actual meaning and context across all of those archived audio and image files. For example, a search for a two-wheeled vehicle will seamlessly pull up a previously saved note about a bicycle. It gets the concept. This means an agent can recall the general vibe of a photo you shared 3 weeks ago just to give you a better recommendation today.
So let's tie the whole shebang together. Part 5, the fully contextual agent.
This is exactly how these 3 layers combine to create those long-running, deeply personalized agents. You've got short-term memory living right there in RAM for your active chats. You have persistent memory living in a database so you can survive application restarts and store basic user profiles. And then you have long-term memory, which graduates to a permanent, multimodal archive for deep semantic search. By orchestrating all 3 of these layers together, you completely solve the amnesia problem. As we wrap up this explainer, I want to leave you with a bit of a provocative thought. Now that your agent remembers everything, from your photos to your voice notes, what will you build next? With AI finally cured of its amnesia, the possibilities for what you can create, from long-running workflow coordinators to deeply, truly personalized assistants, are completely wide open.